Okay. Okay, entonces, example, to understand much better these formulas. Okay, example 1. Example 1 say, find, you need to find the exact value of cosine 75 degree. Well, and you want to find no exact, you have approximate value of the cosine 75, you put in the calculator, and that's it. And the calculator give me a decimal approximation and end the story. Okay, any angle in radian or degree, you can put in a calculator and you get. Basically, so far, the only thing we remember is the fundamental angle 30 degree, 45 degree, 60 degree, and so on. And this is a fundamental. And you remember in the table the exact value, no? The rest of the angle, 31, 32, 47. I have no idea what is that. However, you put in a calculator and you compute the approximate. But in this case, no. I'm using the idea of the new identity that we studied to find 75, because I know that 75, you break it down like a 30 plus 45. Together, addition is 75. The cosine 75 degree is equal cosine 30 degree plus 45. Oh, yeah, I know very well in the table what is the trigonometric function que corresponde with the 30 degree and 45 degree. Okay, let's do it. According to the formula, cosine 30 degree multiplication, cosine 45 degree, cosine is easy to remember, and you don't need to remember, no? Es cosine, entonces the sign is opposite, minus, si es plus es minus, sine 30 degree, multiplication, sine 45 degree. Because I know by memory or looking in the table, in the unit circle, the way you prefer. Cosine 30 degree es radical 3 over 2. Multiplication, cosine 45 degree is radical 2 over 2. Minus sine 30 degree is 1/2. Time sine is again radical 2 over 2. And now multiplication is radical 3 times radical 2 over 4 minus radical 2 times 1 is radical 2 over 4. Okay, if you want, you condense this common denominator gets the same as 4, and you factor out radical 2. And the answer is radical 3 minus 1. End the story. Do you understand or no?
So, Professor, I have a question. So we use the first formula that you gave us.
Well, I'm using the formula for the cosine. Cosine
yes.
of the sum, yeah.
Okay, understood. Thank you.
Let's do an example 2. Example 2 is compute the cosine, the exact value. We are working now exact value, no approximate. Approximate is pretty easy. You put in a calculator and end the story. Pi over 12. Well, I have an idea. Pi over 12 is, I know power 6. It's 30 degrees, no? The pi over 12. It's a half, a 15. So this is a 15 degree. 15 degree. Actually, this is equivalent to say cosine 15 degree. 15, maybe you 45 and 30, no? 45 pero subtract, minus 30. Es 15. Ok, entonces es, Those are basically in radians because my original problem. So I convert to the degree a little bit to understand. And find the combination. Okay, you get 15, 45 minus 30, 15. But actually, this is pi over 4, and this is pi over 6. No, when you're subtracting pi over 6, pi over 4, sorry, minus pi over 6, the least common denominator is 12. 12 divided by 4 is 3 times pi is 3 pi, minus 12 divided by 6 is 2 pi. And 3 pi minus 2 pi is pi over 12. Exactly, we come back at the beginning. So we are doing well. Okay, now I'm using the formula again. The formula is, you want to continue the radian. You can work in degree or radian. I working in, in the original way gets given the problem, gets radian pi over 12 to say I working in the radian, but it's the same. It's the same. So cosine pi over 12. Pi over 12. I discover que es equal cosine pi over 4 minus pi over 6. Y according to the formula is cosine of what? Cosine pi over 4 times cosine pi over 6 plus, it's completely opposite. Cosine is completely opposite sine. Sine pi over 4 times sine pi over 6. This is radical 2 over 2, according to the table. This is 1/2. No. Es radical 3 over 2. A ver. Cosine pi over 6. Es radical 3 over 2, yes. Plus radical 2 over 2 times 1/2. Similar manipulation. I discovered que 2 times 2 is 4, LCD is 4, and radical 2 you see is common factor, is radical 3 plus 1. Similar answer, but this is plus, no minus. You get the idea?
Professor, sorry, I didn't understand. Like, did you transform the cosine of 15 in radians? Okay.
That part?
Yeah, the first part.
Okay, the original problem, Nuela, is given in radian. Entonces, I recommend, but it doesn't matter. The way you prefer. So you are doing well, I agree, good. The original problem is given in radians. Entonces, I convert to degree to understand a little bit the combination of the angle, no? After, I come back again to radian. No 45 anymore, pi over 4. No 30 anymore, pi over 6. Right? Right?
Yeah, right, Professor. I'm listening.
Okay. Let's move on to example 3. In the example 3, we have sine 7 pi over 12. Entonces, bueno, for me it's not clear what is the combination in this case. However, I know, in the previous example, I detecting the pi over 12 is 15 degrees, no? That says 7 times 15 degrees. Actually, when you multiply, it's 105 degrees. And this is equivalent to say sine 105 degrees. The 105 maybe is the combination of 105 is the combination of 45. It's a clue. See, ending in 5 is because 45 participate in the game, plus 60. It's 105. Got it? And this is pi over 4 in radian. And it's pi over 3 in radian. And together, it's pi over 4 plus pi over 3. Its common denominator is 12. 12 divided by 4 is 3 pi. 12 divided by 3 is 4 pi. And 3 plus 4 is 7 pi over 12. Okay, so I confirm this is, you don't need to do that. However, this is confirmation, okay, the selection was correct. sea, split 7 pi over 12 en pi over 4. The sine 7 pi over 12 is equivalent sine pi over 4 plus pi over 3. Do you follow me, guy?
Yes, Professor.
Super good. Now, I using the formula. Okay. The typical mistake que I saw every day es que some students believe que dice sine pi over 4 plus sine pi over 3, and it's totally wrong. No, it's a formula, and the formula says sine pi over 4 multiplication cosine pi over 3 plus the same sign, see, plus and sign. In cosine, no, but in the sine, yes. Cosine pi over 4 times sine pi over 3. And we compute separately one by one. Sine pi over 4 is radical 2 over 2. Cosine is 1/2 of the 60 degree plus radical 2 over 2 again, and this is sine get radical 3 over 2. Similar is the denominator 4, 2 times 2, radical 2 is a common factor, and the answer is 1 plus radical 3. Okay. And you see one professor, entonces every answer is the same, it's similar, yeah. Because it's a combination of 45 and 60, or 45 and 30. It's similar. Do you understand this idea or no?
Yes,
Clear or
Professor.
no? Because I want to complicate a little bit your life. Okay, suppose in the test, in the review, we see example like that. Look. Let me show you. I want to erase the board, right? I can erase or no?
No, Professor, let me just take a picture real quick.
Take a picture.
Okay, I took it. You can erase, Professor. Thank you.
Okay, look at that. In this case, I need to find again the exact value. Find the exact value of the following expression que somehow involve sine, parenthesis, cosine inverse of 1/2 plus. If you want, you put a parenthesis. You know, I discussed in this when you put the name of the trigonometric function cosine, and you put 1/2. Everyone in the world understands inverse, no? Que es paréntesis. Entonces, some people, I don't know why, omit the parenthesis. No, but it's okay, I understand. However, any function, you know, normally in the function notation contain parentheses, no? So you put log logarithm of x. Logarithm of x is possible, right? Yes, it's possible. Most of people write in that way. However, the formal, elegant, strictly, rigorously way is using the parentheses, but it's okay. It's no big conflict. So you omit the parentheses. And sine inverse of 3 over 5. Okay, let me analyze the idea of this. We have trigonometric direct and trigonometric inverse. And you know que the answer que offer the trigonometric inverse is an angle. I want to call this angle alpha, Greek letter. And this guy is beta. Actually, I change my problem like that. Sine alpha plus beta. And you're using the formula. The formula is sine alpha times cosine beta. Cosine beta plus cosine alpha sine beta. Okay, and who is alpha and who is beta? This is the most important one. Okay, si you suppose que cosine inverse, if you suppose que cosine inverse 1/2 es alfa. This is equivalent to say que cosine alpha is equal to 1/2. Right? Entonces now you see, oh, what is the angle whose cosine is 1/2? Oh, it's pi over 3. Therefore, alpha is pi over 3. Do you follow me? Do you follow me or no? Yes or no?
Yeah.
Another hand. Yes. If sine inverse of 3/5 I call beta. This is equivalent to say que sine beta es 3/5. Pero 3/5, I don't see in the table 3/5. So when you don't see something in the table, that means that this is not fundamental angle, and to compute another trigonometric function, we need to do the famous triangle, no? This is my beta angle, and sine by definition is opposite over hypotenuse. And this is the famous triangle that is 3, 4, 5. This guy 4. You want to make sure you compute it like that. 25, 5 squared minus 3 squared. This is 25 minus 9 is 16, and the square root is 10 and 4. But I know by memory the famous 3, 4, 5 triangle, right triangle, 90 degrees. Okay, so I come back at the beginning. Who is sine alpha? Bueno, sine alpha is sine alpha, que by the way is pi over 3. I detecting in this case not necessarily triangle in this first is radical 3 over 2. I know for the table, no? This guy is radical 3 over 2. Multiplication by cosine beta. Who is cosine beta? Oh, cosine beta. I know the sine, but cosine no. Cosine I know by definition is adjacent over hypotenuse, 4/5. Multiplication, this guy is 4/5. Plus cosine alpha. Well, cosine alpha I have at the beginning, 1/2. Time sine beta I have 3/5. Now multiplication. This is 4 radical 3 over 10. So 2 times 5 is 10, 4 times right. And this is plus 3 over 10. Okay, 1 times 3 is 3, 2 times 5 is 10. So you have the same denominator. Nice, I like that. The answer is 4 radical 3 plus 3. End the story. Final answer. Do you understand or no?
So, Professor, I didn't understand after we substitute like the formula for the values. I didn't understand that part.
Okay, Noela, look, the formula say, I want to recopy again for you. Sine alpha multiplication cosine beta plus cosine alpha times sine beta. Sine alpha, I know que alpha is pi over 3, que es 60 degrees. Entonces, sine 60 degrees is radical 3 over 2, and just replace. This is no sine alpha anymore, is radical 3 over 2. Multiplication cosine beta. Cosine beta in the triangle. This is beta is no fundamental angle. Alpha, yes. Alpha is 60 degrees, pi over 3. And beta, no. Beta, I have no idea. It's a crazy, no fundamental, intermediate angle. Okay, the only possibility is to compute sine or cosine, and approximation is using the calculator, no? But no, I don't want approximation. I want exact answer. So in the triangle I saw, okay, by definition is cosine is the ratio between adjacent side, que 4, divided by hypotenuse, que 5. This is 4 over 5. Plus cosine alpha, bueno, cosine alpha I have, que 1/2. I have at the beginning. And sine beta as I have at the beginning also, 3, 5. The rest is multiplication and addition. Yes or no? Super
Yes.
cool?
Yes,
Okay.
I understood now.
Any question with respect this example number 4, no? No, it doesn't matter. Number 1 of the new part is when you have combination, trigonometry direct and trigonometry inverse. Okay, the most important, guys, is, you know, it's hard to understand. You have two kinds of trigonometric functions. The direct trigonometric function, in which the domain that you plug in inside the argument is an angle. Okay, you have sine. You plug in angle inside the argument. And the answer is the value. This is the idea of the direct and the forward direction, and the reverse direction is sine inverse. It's completely different. You plug in the value and give me the angle. The answer, you can express it in degree or in radian. Okay, do you understand this idea clear or no?
Yes.
Okay, let's move on to the next example. Very, very interesting. Okay, suppose this example. And this example is the same objective. Find the exact value. This is cosine of the sine inverse of 5/13 minus tangent inverse of 3/4. In this case, I complete a whole the parentheses to understand much better the idea, no? Entonces, the procedure is always the same. You have two angles, and you call alpha and beta. Okay. Entonces, my expression now is cosine alpha minus beta. And you're using the formula. The formula is cosine alpha times cosine beta plus opposite side sine alpha sine beta. This is a formula exactly. I copy and paste for the cheat sheet. Okay, so I dedicate now to investigate who is alpha and who is beta. Okay, I know. Look, the alpha is equal to sine inverse of 5/13. This statement is equivalent to say que sine alpha is equal 5/13. Okay, entonces now this is no fundamental angle. This is weird. So I'm doing my triangle. My triangle only for the alpha. This is alpha. According to the definition, sine is opposite over hypotenuse. Okay, now the other leg is important because I need to find cosine is square root 13 squared minus 5 squared. 13 squared 169. 5 squared is 25. And we use subtracting 144. And the answer is 12. Okay, super. Entonces, in my formula, in the alpha part, I need the sine here. I need also the cosine. So I take advantage and compute the cosine. Cosine is 12/13. Adjacent over hypotenuse. So far it's clear. I have in my hand this guy and this guy, que corresponde with the same triangle, que es the alpha triangle. Good or good?
Good.
Let's move on to the beta. Beta angle is tangent inverse of 3/4. This is equivalent statement to say tangent beta is equal 3/4. Yeah, I'm doing one similar triangle for the beta. It's a beta. 90 degree, 90 degree. And definition for the tangent is opposite over adjacent. And this is the famous 3-4-5 triangle. Yes or no? If you want to compute, you can, but not necessary. Entonces, I need in the formula for beta, cosine, and sine. Cosine beta is 4/5 adjacent over hypotenuse, and sine beta is 3/5. Okay, now substitution. Every information that we have in the new formula that we are studying today. Okay, substitution here. Who is cosine alpha? 12/13. Time. We are doing this time. Who is cosine beta? 4/5. Plus sine alpha is 5/13. Time. Sine beta, que es 3/5. Okay. Okay, now multiplication is 48. So 12 times 40, 48. Divided by 13 times 5, 65. Plus 15 over 13. Okay. 65 again, because it's 13 times 5. Combined together is 63 over 65. End the story. I finish. Any questions?
That one was clear.
Yeah. The beginning always is confusing, no? But okay, so I have another kind of problem, similar, but a little bit different, in which the objective is a little bit different. Let me know if I can erase the board or not.
You can, Professor.
Okay. Sometimes happen in calculus que you manipulate and you have the trigonometric expression. Trigonometric expression. However, this expression is no good for you, and you can change to algebraic expression. This is typical of Cal 2. Cal 2, you know, Cal 2 is horrible, guy. You need to know a lot of things. This is trigonometry, this is level versus subject. College algebra, like that. Trigonometry, a little bit like that. Pre-calculus, a little bit like that. Pre-calculus, in my opinion, is easier than trigonometry. Calculus 1, like that. Cal 1. It's hard, but no, not too big. And Cal 2 is, yeah. Okay? You need to know a lot of algebra, complicated algebra, trigonometry, everything together. Cal 2. You need to take, right? Or no?
Just the one, Professor. Thanks, God.
Only one? Only one?
Yes, just calculus 1, and then I'm done with math.
Okay, super. Good for you. Okay, so now this is the objective. Suppose que you manipulate and you get the trigonometric expression and you need to convert to the algebraic expression. Okay, let's do it. Suppose this cosine inverse u, no numbers, you know, it's variable, u, whatever, plus sine inverse b. Convert this. This is trigonometric expression. Yeah, I want to show you in a few minutes. I want to convert to algebraic expression. No No sine and cosine anymore. No sine and cosine anymore. Okay, therefore I apply the same idea. I call this alpha. I call this beta. Therefore, I have cosine alpha plus beta. And I know the formula. The formula is cosine alpha times cosine beta minus opposite sign sine alpha sine beta. Wow, no good. Sine beta. Okay, so I need to do two triangles. Okay, so I know by definition I create by myself alpha is cosine inverse of u. U is a variable. X, Y, Z, either. This is equivalent, see I swap to the trigonometry direct function like cosine alpha is equal to u. So I'm ready to make the triangle for the alpha. Remember, alpha and beta as angle, and you suppose always in that corner, always, because that corner is 90 degrees, and the other corner is the complementary, alpha is 90 minus alpha. Okay, now, according to the definition of the cosine, cosine is the ratio between adjacent over hypotenuse. But I don't see anything in the bottom, so I suppose default is 1, no? U over 1 is u. So this is u, and this is 1. And the other leg is square root 1 squared minus u squared. 1 squared is 1 minus u squared. Everyone follow me so far?
Yes.
Entonces I have in my hand cosine alpha, que es u. Just u. So I would like to erase that part. And sine of the same triangle, sine alpha, is the ratio between opposite and adjacent. Gets square root 1 minus u squared divided by 1. No? And you know 1 is invisible factor. So it's just square root 1 minus u squared. Okay. Likewise, beta is sine inverse of the one variable called b. This is equivalent to say cosine, sine beta is equal b. It's doing the triangle. Oof. Nice. This is better now. 90 degrees. So the sine, by definition, is opposite over hypotenuse, que es 1. Same idea. When you see nothing in the denominator because it's 1. And the adjacent is 1 minus b squared. And the cosine beta, que is the only trigonometric function that we need in that formula, is adjacent over hypotenuse, que es 1. I am ready. I come back. Here. Our algebraic expression is equivalent to the trigonometric. This is cosine alpha is u. I replace u. Multiplication time cosine beta is square root 1 minus b squared. Minus sine alpha is this square root 1 minus u. This is a u and this is a b. Don't confuse it. It's different. Time sine beta, que es b. Okay, if you want to put more elegant, this expression is equivalent u square root 1 minus b squared minus b square root 1 minus u squared. Boom. End the story. Algebraic expression equivalent to trigonometric expression. Do you understand the idea? Do you understand the idea?
Yes, Professor. We just substitute the formula, right?
Ah, that's it. It's super easy. It's super easy. Mechanical. No big deal. The problem is, to be clear, in the trigonometric inverse function and direct trigonometric function. But I promise that throughout the chapter, we practice a lot of. I bring as soon as possible the big review, que summarize everything at the beginning. The problem is that you need to not memorize, but be familiar with the formulas and apply in your corresponding moment. No? Okay, I have another example similar to this. May I erase or no? No? Not yet?
Yes, Professor, you can.
Okay. Okay. Next example say sine inverse of u. I don't know why in this kind of problem using u and b always, but it doesn't matter. Minus cosine inverse of b. Same procedure. I call this guy alpha. I call Greek letter because I know that the answer que offer the inverse trigonometric function is an angle. In degree already. Entonces now, this is equivalent in my mind like a sine alpha minus beta. I know the formula que es sine alpha cosine beta minus the same sign cosine alpha sine beta. It doesn't matter the order, guy. But it's easy to remember because you put sine in the alpha, you put the cosine alpha, you put the cosine beta, you put the sine beta, opposite. Okay. Now, let's move on to the triangle. I know the definition of the alpha is sine inverse of u. Okay, it's equivalent statement to say que sine alpha is u. Let's do it in the triangle to see much better. And you see the student can take to take calculus 2. In one moment of the calculus 2, the professor doing this triangle. And some people say, wow, what the hell is that? What is the participation? This is the participation. It's the conversion trigonometry expression to algebraic expression. Because the history is complicated. You have something that you see in calculus 2. The name is integrals. You see in calculus 1, but in calculus 2 you see more intensive. And there are one method for solving the integral, that is using trigonometric substitution. And when you change algebra to trigonometry, the integral made easy. Wow. And you solving super easy, fast. Now, but you get the answer in trigonometry expression. But no, see at the beginning, there are no trigonometry, nothing. What to say, I need the answer in algebra expression. And you doing the conversion very, very similar to this. So the teacher doing the board, one triangle, and the student say, what the hell is this triangle? No, it's the idea to conversion, trigonometry expression to algebra expression. Okay, so now we have u as the opposite. This is alpha, and the hypotenuse 1, no? And this is square root 1 minus u squared. I need an alpha, sine, and cosine. So cosine alpha is square root 1 minus u squared divided by 1. Super. Likewise, beta. According to my definition, cosine inverse u not b, sorry. It's equivalent to say cosine beta is equal to b. And we have another triangle for b. Is it beta? 90 degrees. Cosine by definition is adjacent over hypotenuse. Okay, when it's invisible, you suppose it's 1. Suppose no, you know it's 1. And this is square root 1 minus b squared. I need to find cosine here, and beta and sine. To find the sine is opposite over hypotenuse. Okay, so what is the final answer? The final answer is sine alpha time cosine beta b ub minus cosine alpha radical u1 minus u squared time sine beta another square root 1 minus b squared. And you can leave it like that, perfect. You put together this, you put together like that, no? But this is a cosmetic, stupid algebra, no? Okay? This is totally irrelevant, no important. Any question? Do you follow me or no?
So, Professor, the thing that I didn't understand is like the way you did the triangle. Why did you put like 1?
Because, for example, in the sine alpha, you know, sine by definition is the ratio between two quantities. Sine alpha is opposite over hypotenuse. No? But in this case, we have no ratio, we have only one value. That means that u is opposite and 1 is the hypotenuse. Because it's u over nothing over 1. And here exactly the same. Do you understand now?
Yes, I got it. Thank you, Professor.
Remember, any trigonometric function comes from, for the definition, gets a ratio, a division between two quantities. So you see gets equal u, because opposite over hypotenuse. Opposite u, hypotenuse 1, because it's invisible. Make sense?
It does. Thank you.
One more example of this, similar. Similar. You raise the board or no?
Can I take a picture, Professor, real quick?
Go ahead.
Okay, I took it.
Oh, this is tangent. Sine inverse u minus cosine inverse b. Okay, so I call two angles, alpha and beta. You can use in any letter. But I call, because I try to relate with the formula that we have in the Chichino, tangent alpha minus beta. So I use the identity for a tangent. The identity for the tangent is a little bit more complicated. It's tangent, you have fraction. It's tangent alpha minus tangent beta 1 plus opposite side of this. See, this is minus in the top and positive in the bottom. See, this is plus here, a plus in the top and minus in the bottom. Multiplication tangent alpha times tangent beta. Okay. So I copy that and I waited for the last moment. Now I do my famous triangle to the transformation from trigonometry to algebra. So I know that alpha is sine inverse of u. Que that is equivalent to say que sine alpha is u. Let's do it in the triangle. Is it triangle? Wait, no good. Right. Triangle. I try to do my best. This is 90 degrees. This is alpha. And sine is the ratio between opposite and hypotenuse is 1. Therefore, this guy is radical 1 minus u squared. Okay, but I need tangent. No sine, cosine. In our expression contain tangent, but no problem. Tangent alpha is the ratio between opposite and adjacent. Entonces, u over square root 1 minus u squared. For a moment, leave it like that. After, if you want to rationalize something, but leave it like that for a moment. Let's come back to the beta triangle now. Beta is cosine inverse of B. Okay, it's equivalent. To see more clear, in my mind, in my opinion, I don't know, I respect, in the direct trigonometric function, is cosine and beta equal B. And we have a triangle for the beta. 90 degree beta. And this is B, and this is 1. And this is square root 1 minus B squared. Therefore, tangent beta is the ratio between opposite over adjacent. Okay, so I'm ready to substitution and manipulate a little bit algebraically the expression in order to put it more elegant, but it doesn't matter. Entonces, tangent alpha, who is tangent alpha? This is tangent alpha. U over square root 1 minus u squared. Minus tangent beta, square root 1 minus b squared. This is b, sorry. Divided by p. Divided by, this is division, this is not division. 1 plus multiplication this guy. Okay, this guy is u square root 1 minus u squared times square root 1 minus b squared over b. Wow, look like horrible. Don't be scared. You leave it like that, perfect. However, let me try to do one transformation in order to put more elegant. This is cosmetic part. If you multiply top and bottom by b radical 1 minus u squared, it's obvious, multiply this and this by the same, doesn't affect, no? It's ub, because this radical and this radical cancel. In this case, no, is cancel the b, only the b. This is minus radical 1 minus u squared times radical 1 minus b squared. This is elegant, more elegant. However, in the bottom is multiplication this by chi1 is b radical 1 minus u squared plus and this is cancelled, and this is also cancelled and stay alive only u radical 1 minus b squared. Okay, this expression is completely equivalent to this. However, this is appreciation, no? This is nice, and this is ugly, no? But it's okay. Everyone follow me? Everyone understand the thing I'm doing? So the topic was conversion. Yes. Conversion. The topic was conversion. Trigonometric expression to algebra. No sine and cosine, ni tangent, ni nothing anymore. This is the idea behind that topic. So I want to dedicate the rest of the time doing 1, 2, 3 problems. Yeah, 3 problems. I don't know, I have more. Well, let's do it. Everything here. Okay. Suppose. Using your imagination, common sense, I can erase the board.
Professor, give me just a second. I just want to take a picture of the last part.
Make it zoom to see more elegant.
Okay, sounds good. Thank you.
Erase now. Okay. Again, it's similar to the problem we are doing at the beginning. Compute the exact answer of the sine negative 11 pi over 12. Wow, at the beginning I'm confusing because I know que pi over, well, first of all, the negative sign. Remember that always I say you que don't frustrate with the negative sign because you apply the even odd property. Yeah, I know que sign is odd function. So you put negative sign of the 11 pi over 12. Now, the answer that we get of this part, you affect by -1 and in the story. Yeah, I solving the problem of this. On the other hand, I have to get pi over 12. We discussed before a 15 degree, no? And 15 degree times 11 is 100. So actually, 11 pi over 12 is 165 degrees. Okay, entonces now, one, you know, idea. See, my angle is ending in phi, it's because participate 45, no? Because another angle 30, 90, 60, ending in 0. Entonces, si at least I have phi, es obvio que 165 is the combination 45 plus something. I suppose que es 120, no? Because it's 165. So in my mind, immediately, I suppose que this is equivalent to say, and it's a pi over 4. Pi over 4. And I come back to radian, no? Because in radian, it's hard to see, however, in degree is easier, and this is 2 pi over 3. 60 times 2 is 120. So let me check it. Pi over 4 plus, this was plus. 2 pi over 3 is LCD is 12, 3 pi, plus something, this is 4, 8 pi. And 3 plus 8 is 11 pi over 12. Nice. Then basically, wow, I realize, of course it's negative, don't forget that negative. If you want, you omit, another way to organize the job is, forget about this, and you copy down sine 11 pi over 12, no? Yeah, I know that this answer, finally you multiply by -1 in order to get the final answer. So I break it down, 11 in sine of pi over 4 plus 2 pi over 3. Do you follow me? Everyone follow me?
Yes.
Now, I apply the formula. What formula? The sum alpha plus beta is sine pi over 4, que es the first, time cosine the second, que es 2 pi over 3, plus the same sign and sine the second, que es 2 pi over 3, time cosine pi over 4. I assume that this guy is alpha and this guy is beta, no? I copied exactly this formula. You want, you copy cosine of sine, sine alpha. It's a trigonometry identity. Exactly, I copy of the cheat sheet and paste in the whiteboard. Cosine beta plus sine beta cosine alpha. Cosine alpha, yes. And you replace. Sine pi over 4 is radical 2 over 2. Cosine 2 pi over 3, oh, I don't remember. 2 pi over 3 lie in what quadrant lie? In what quadrant lie 2 pi over 3, 120 degrees? Hey, in what quadrant lie 120 degrees?
Second.
Second,
very well, second. This is my famous 120 degree. Entonces, in order to find trigonometric function of the another quadrant different to the first quadrant, you find the famous reference angle. The reference angle in this case is this guy. Que existe. Entonces I know very well que the value for this trigonometric function is exactly the same of the cosine 60 degree. And cosine 60 degree I see in the unit circle or in the table, que es 1/2, no? Right?
Right, Professor.
But you adjust the sign. What sign do you believe que this cosine have? Positive or negative?
It's going to be positive.
No, because cosine is negative in the second quadrant. Remember the mnemonic divide. All students take calculus. Do you remember that or no?
Yes, it's like sin and secant they are positive on the second quadrant, right, Professor?
Ajá, entonces cosine es positive o es negative. We are talking about, o sea, we focus in the bar. This cosine in the second quadrant is positive or is negative?
Negative.
What value?
Negative 1/2.
Exactly. Plus, and like what happened here, que es the reference angle is sine 60. Pero sine 60, I know que es radical 3/2, no? But what sign? Is positive or negative? Sign.
It's positive because it's in the first quadrant.
Exactly. Look at that. Student, sign. Radical 3/2. Multiplication by radical 2/2, que es cosine. Entonces, basically is negative radical 2/4, the multiplication, this and this, this and that. And the multiplication, this and this is radical 3 times radical 2/4, no? Don't forget, this is the crucial moment, this negative. Because I manipulate without negative. Entonces, si es negative here, it's obvious that the first part becomes positive and the second negative. If you want, I like that, but not strictly necessary. The LCD is 4 and radical 2 is common factor, entonces we have 1 minus radical 3. And it's my beautiful final answer. Super cool.
Professor, I have a question. The test, can we leave in like that, or we need to put like this in these like final answer? We need to combine all of them. We can leave like.
Okay. The answer is I accept anyway. So you leave it like that, it's perfect. However, Alex, no. Alex picky. Alex picky. Alex, suppose that you have the answer 2/4. And you leave it at that, Alex, this is wrong. Because you suppose that Alex, suppose that you reduce the lower 1/2. Okay? Entonces now I recommend you see the example first. And you see the algebraic manipulation that we need to express the finals. Okay? Well, thank you. Well, I say, okay, thank you. I know, I asked it because it's equivalent. I know it's ugly. But no, it's okay. It's acceptable. Okay, one more example. One more. Similar. Suppose cosine 5π/12. Compute the exact value of this. As you put in any regular calculator, give me a decimal. No, they are sophisticated calculator in which you sometimes get the exact answer, sometimes no, not always, because it's very, very complicated. But okay. Entonces now we're doing by hand, no calculator, definitely. Entonces one more time happen que es 5/12 is 15 degrees. You know that. A multiplication by 5 is 65, no? 65, yeah. 5π/12 is 65 degrees. One more time, entonces 65, we can write like a combination of 45 plus something, no? 45, but no. 65, not 75, no? 75, sorry, I make a mistake here. Okay, it's 15 times 5. Now let me put in a calculator. 15 times 5 75, es obvio, ¿no? Pues, entonces, no 65 es 75. 75. And it's 30, no? Actually, it's pi over 4 and pi over 6 together. 180, 180, okay, it's another possibility. No era 6, how you convert that? You divide by, remember the formula, guys. 5 pi over 12, you divide by pi and multiplication by 180. And you get 75. Okay, entonces you determine que the 75 is given by the combination 45 plus 30, ¿no? O the combination pi over 4, que es 45, and pi over 6 is 30. This common denominator is 12. 12 divided by 4 is 3, times pi is 3 pi, plus 12 divided by 6 is 2 pi, and 3 plus 2 is 5 pi over 2. Okay, immediately I detecting okay, this you can reduce it like a cosine pi over 4 plus pi over 6. Okay, no all the problem we can solve in this. This is a specific problem that is prepared for you in order to practice this inequality that we studied today, que is the sum of difference, the angle, right? Not always, but in this case, yes. Entonces, you know, let me erase that part. I suppose you understand very well. Entonces, we're using the famous identity, que es cosine, cosine, sine, sine, pero es minus, because it's plus. Entonces, cosine 45, pi over 4, times cosine pi over 6, minus sine pi over 4, times sine pi over 6. Okay, this is radical 2 over 2, times, this is radical 3 over 2. This again is radical 2 over 2, it's the same, sine and cosine is the same, and it's 1/2. Entonces radical 2 times radical 3 over 4 minus radical 2 over 4. Over 4 LCD, radical 2 is a common factor, radical 3 minus 1. Elegant answer. Ugly answer. Okay. One more, the last one, I promise. Let me see what time it is. See the last one. Yes. Suppose I need to find the exact value of sine 15 degree. Wow, how you get 15 degree? Well, you get like a 45 minus 30, right? 15. 5, 4. So you can write 15 is sine 45 degree minus 30 degree. I know very well the exact trigonometric function 45 and 30 because it's a fundamental angle. And this is sine 45 times cosine 30 minus, in this case, it's perfect coincident sign. In this case, no, it's plus and minus. In this case, plus and plus, or minus and minus, or plus and plus. Minus sine 30 cosine 45. This is radical 2 over 2. This is radical 3 over 2. Minus, this is 1/2. And this is radical 2 over 2. Same manipulation. The common denominator 4. Radical 2 is factored out. Radical 3 minus 1. Wow, unbelievable. Any answer is similar. Look, this and the answer, and this answer is the same. It's the same. And make sense or not? 15. The last it one. Does. Yeah.
Because of the angles.
Pero make sense or no? Let me see. let me try to understand. 15 degree look like that, 15 degree. And this angle was, I remember the other example was 75, no? 75. Ah, yeah. The reason is because this is cosine and this is sine. 75 look like that. But 75 and 15 together is 90. They are complementary. Therefore, using the cofunction property, sine of the one angle is equal cosine of pi over 2 or 90 degree minus the same angle, because of co-function idea. Okay, guys, too much. It's enough for today. Next week, we continue another property. Okay, and immediately I want to dedicate at least 3 lectures doing the review at the beginning. Okay,
Professor, I have a question. Professor, I'm going to teach calculus on